VI characteristics of diode. It is very important to know how a device responds when it is connected in an electrical circuit. And this information can be obtained by means of a graph known as VI or voltage ampere characteristic. It is a graph between applied voltage across the terminal of a device and the current that flows through it. The VI characteristic of PN junction is shown over here. The whole graph is divided into two parts. That is the first quadrant, that is for your forward biasing, or it is called as forward characteristics. Whereas in the third quadrant, we are getting the graph for our reverse characteristics. Now we are going to study in detail about forward and reverse characteristics. So firstly, we are seeing forward bias characteristics. To get the forward bias characteristics, the first step is we need to connect the circuit as shown over here. Here you can see that initially the diode is connected in forward bias, that is the positive of the diode is connected with the positive terminal of the battery and the negative of the diode is connected with the negative terminal of the battery. In we are giving the current, we are measuring the current with the help of ammeter which is connected in series with the diode, and we are also measuring the voltage across diode with the help of voltmeter which is connected in parallel with the diode. We are also using potentiometer with the help of which we are gradually increasing the supply voltage in small steps of about 0.1, and we are recording the values of the diode current with the help of ammeter. By plotting the values, we are getting a graph, or as shown over here, that is a curve of O, A and B. In the graph, you can see that till point A, we are not getting any output. This is because the external apply voltage is opposed by the junction voltage of the diode, whose value is 0.7 volt for silicon and 0.3 volt for germanium. However, as the voltage increases about point A, there is a rapid increase in the current, as you can see from point A to B. This the voltage at which this current increases rapidly, it's called as knee voltage, cut-in voltage or threshold voltage. We can also see that at this voltage your diode will start conducting. So this was about your forward bias characteristics. Now, checking for the reverse bias characteristics. Here, initially we are connecting the circuit as shown in the diagram. That is, first we are connecting the diode in reverse bias. We are using a potentiometer to change the value of our reverse voltage. We are using ammeter in series with the diode to measure the value of the current. And we are also connected a voltmeter across our diode. Initially, the applied reverse voltage is gradually increased above zero in suitable steps, and the value of the diode currents are recorded. By plotting the values, the output graph, that is, we are getting a curve of O, C, and D. Here you can see that when the applied reverse voltage is less than your breakdown voltage, we are having a small diode current, a constant value of a diode current. This constant value, this small constant current is called as reverse saturation current, and it will be in nanoamperes in silicon and microampere in germanium. When we are increasing the reverse voltage, there you can see that the current increases rapidly. That is the curve C to D. And the point at which this happens is called as a breakdown voltage. At breakdown, we can also see that it might damage your diode. So this is your reverse bias characteristics, and I'm combining both of this graph. We had initially seen the curve that is forward and reverse bias characteristic is called as VI characteristic of a diode.